Now let's go to chapter 1. Some of you has taken up engineering subjects, particularly of all mathematics and engineering sciences. You come to know all of your professors who are very thorough. And you are, if you don't know on this one, they are very strict about it. So those who are engineers right now there in the field, who are practicing their own field, then you come to experience that now how studying in engineering is so difficult and so very easy. Especially you have to go know the different styles of professors. Now, some of that are having a scholarship interpretations of the subject. Some of it, as the students are having a difficulty of grasping it, just because of how they enhance, of how they convey the informations out from the textbook that we have learned, that you have learned from those days. And until now, let us confer of how those difficulties from those generations that we have and until now compares the difficulties and complexities out on learning of these subjects. Calculus brings back a lot of fears before that we have for engineering students before, because some of this they keep it repeating subjects because they cannot grasp how difficult it is on that. Some of that are very easy to grasp the subjects, especially on the fundamentals. Now, how this Professor Thompson's or Sylvanus Phillips Thompson interpret of this calculus, of this, is in a layman's term. Especially when we are learning about this calculus, we will be getting how to differentiate, so that we have a differential and integral calculus. So this is a kind of mathematics where we have to study the portions of how particular items, when you study it, you have to study portion by portion. So you have to consider the small portion of it. How could it affect the particular subject, the particular quantity can grow, can grow into a more small portions. Now, are you familiar with this one? Most of the students are familiar with this. What is this? And what is that? That symbols. So particularly on this calculus, we will be dealing a lot of variables and constants. This is the algebraic expressions that we will be dealing on that. Then we come to know that this one and this one here are the symbols that it could get us so difficulty that just like forget it about it. But you see, this particular letter denotes that it means something when we are dealing about this variable x, y, and z. So when we are differentiating about it, it means to say that we will go to comprehend, we will go have to comprehend or a differentiations about x. It means to say a little bit. So when we have to consider about these variable items, it's meant to say that a portion of x, so we have to get a portion of it. So d It's meant to say is a differential of x. So when we have to make this dx, which we call it dx, so let's say in engineering terms, dx, it's meant to say a little bit, a fraction of it. So a fraction of it means to say that we are gonna have to grasp it. We have to determine it. Now, on this particular items, portion of it, this could be the topic that we are going to get into. We have to find a portion of x, whether it is increasing or decreasing. So as we go on this differential calculus, we'll be involving this quantity x, y, and z. Sometimes it can go u, v, w. No? It could be we will be also working on this t. Now, this one is the differentials. Means to say is a little bit, a fractions of x. A certain amount, a particular amount that we would want in finding x, in finding these items. Now, if we will see on this portion also in the calculus, this long s, this is a long s. This according to Salbanas, this is a long s. A long s. Means to say, in mathematicians and regular mathematicians, we put it as an integral. Means to say, is the whole of this x. Okay? The whole of this x as z. And all of these algebraic expressions that we have to determine on that. So, log s meant to say the integral all, shall we say in layman term, whole. So, the differential calculus is meant to say a little bit. So, we'll examine portion by portions in a degrees. In the various degrees. In the second chapter, we'll be dealing this one with the various degrees of smallness. Now, let's say this one. How we could get this expression of this? Are we clear? Because some of our professors before is just like they are putting this one, they are telling about it, this is the integral and this is differentials. But it's my first time to know about this old script before from 17th century, from this famous physicist that is dealing this about it, that we will be dealing this one to determine a portion, a proportion of it, in how many degrees. So it means something that there's no important about it, that we will have to consider also the smallness of all these things. You see? Now, in 1 hour, you see the difference of this one? Wait a minute. Wait a minute. I will be there. So there's an important that the ticking of the clock, the ticking of an hour or every minute, there's an important meaning of it. So in 1 minute, how does it spend time? Would it be beneficial of that? Would it be beneficial? Would it be important for you on that? How many works or how many development works that can be achieved in 1 minute? In 1 hour. How many minutes in 1 hour? Isn't it 60 minutes? Now, for 24 hours, how many minutes for 24 hours? Would it become important on that? Now for 7 days or 1 week, for 7 days, would it become importantly that 20,008 minutes? Would it be work? So a portion of that minutes can grow or become negligible or not negligible. But you see, part of it, you will become familiarized of that, and you have to consider it little by little as we go on this. So when you start off it, when you see this term dx and dy, or an integral of that of x dx, we meant to say that we have to start calculations. We have to start this operation and calculate it. But fundamentally, we have to dig it portion by portions of how we mean to dissect in order that we could attain the wholeness of this portion, of this variable. Now, the wholeness of variable, it means to say that a little bit of something of this x, we meant to say that if there is a development, there is an increase of it. Okay? If there is an increase. So, as we go on the second chapter, we will be dealing on that one of the various degrees of smallness. Then we could define, really to know and explore the basic fundamentals of exploring calculus.